All right, today we are doing absolute value equations. So the equations, let me call this the video. The equations is going to be day 1, and the inequalities will be day 2. So equations, first we need to talk and remind ourselves what is absolute value and how are we using it now in algebra. So absolute value, this is what absolute value is. How far away from 0 a number is. So absolute values are represented something like this. A line, and I'll do like the absolute value of -3. So it's a straight line up and down. This is a grouping symbol. You know, grouping symbols can be parentheses or brackets. This is an absolute value. And it just means if I look on the number line, so everyone look at the number line, the alphabet letter J. How many spaces is J from 0? How many spaces is -3 from 0? Someone out loud, tell me. 3, which means I'm not going to say it's -3 spaces away. I'm not going to say I live -5 houses away from you, or I'm -2 buildings. My class is -2 buildings away from yours. It's true value. How far away? What is the number's value? So in this instance, the absolute value of -3 is just 3. And then if I had like a whole number that was positive, the absolute value of 5 is 5. The only time an absolute value would end up being a negative answer is if I gave you something like the negative absolute value, even if I put -7 in here. So forget about the negative in front. The absolute value of -7 is 7. This negative would then come in front, and that's the only time that I would have a negative result in an absolute value problem. So in an equation that we're going to do today, we're going to solve, and there's going to be an absolute value symbol in the math problem. So basically it's going to be, if I had, and I'm going to use some of the space down here. If I said, okay, well, the absolute value of -3 and then the absolute value of 3. Aren't these both, we just talked about it, aren't these both just going to come out as 3 spaces away from 0? So basically I have 2 answers, a negative and a positive. A -3 equals 3 and a +3 equals 3. A negative and a positive. And a positive. So in my absolute value equations, I'll write it over here in the margin. Equations and inequalities, so today and tomorrow. Absolute value equations and inequalities have 2 answers. So this first thing we need to do is isolate the absolute value, ab-val, symbol. Means get the absolute value all alone. And then step 2 is going to be write 2 equations, a positive and a negative. And we have like hardly any space. All right, so here's how this works. If I've got 7, will you put this over here on the upper right? Space is limited. You need to first isolate this absolute value symbol because I cannot do a negative and a positive if I have other stuff cluttered next to my absolute value. That means that this 2 needs to be moved to the other side. So I'm going to subtract 2, and I put BS for both sides. Subtract 2 on both sides. So 5 equals the absolute value of x. This is where I write my 2 equations. What numbers can I plug into x and get a positive 5 out? What number could I put in this absolute value symbol and get a positive 5 out? I could do that x equals 5, or I could plug in what? Negative 5. So I have 2 answers, and this one's pretty easy because there was no math inside the grouping symbol, inside the absolute value. So I'm isolating the absolute value, getting that alone, and then I'm going to make 2 like branches, and I'm going to do a positive version and a negative version. So right here on B, I'm going to do just that. I'm going to look and say, okay, is the absolute value isolated? Is it the only thing there? Yes, it's the only thing. So I'm going to make 2 lines, and it's going to be the number after the equal sign. The number after equal sign is, I do a positive of it, and I do a negative of it. So I'm going to do 2x minus 3 equals positive 1, and 2x minus 3 equals negative 1. So it's always after the equal sign. You're going to have to write small. So add 3, 2x equals 4. I'm going to solve the left and I'm going to solve the right. Once I make my 2 branches and I split this up, I don't have to write the absolute value anymore because I'm making a positive version of it and a negative version of it. X equals 2. And then I'm going to solve the right-hand side, negative 1. Two x equals 2. Negative 1 plus 3 is 2. Divide by 2, x equals 1. So my 2 answers are x equals 2 and x equals 1. That means that I can plug 2 back into my original. 2 times 2 minus 3. 4 minus 3. Yeah, that's 1. And I can plug 1 in. 2 times 1 minus 3. That'd be negative 1. The absolute value of negative 1 is 1. Okay. On this one, I'm going to do it right here. Let's see where, okay, in the next, let's do it in the margin right here. Can you turn the page, next example 2? I want you to have plenty of space. It's not fair for you to have to smush everything in. Can you write the problem again? There it is. 3 times the absolute value of x plus 6 plus 8 equals 5. Isolate the absolute value. I'm going to subtract 8 first. Minus 8, minus 8. So now the 8 is gone, but still I have a 3 times the absolute value of x plus 6 equals negative 3. Okay. Divide by 3. because I have to get rid of the number in front of the absolute value. Okay. Sadly, I said to you, negative 3 divided by 3 is negative 1. Can I, like, if I put a number in this absolute value symbol, can I get a negative out? There's no negative in front of my grouping symbol here. Is there a number that I could plug in and get a negative 1 out? Like if I plug in negative 1, absolute value of negative 1, that still equals positive 1. So how am I going to get a negative result? I'm not. You cannot have a negative answer to an absolute value ab-val equation. This equation has no solution. So we can't solve this. This equation has no solution. Okay. Let's look at example 2. We're going to solve a lot of them together. We're not done. We're going to do some homework or classwork together. Okay. So the cruising speed of Kennedy's boat is 25 miles an hour. We're doing the example 2 word problem. She plans to cruise at this speed for the distances shown. So she's going to go 80 miles. And what equation models the number of hours x that Kennedy will travel? Okay, well, she is, it says, negative 10 miles plus 10 miles. So what that means is she is 10 miles from the 80-mile point. So what we're going to do is we're going to say that she's going to travel, she's going to do 25 miles an hour, and it says the number of hours. So this is going to be rate times time. And that's going to be 25. That's her rate. Number of hours, I don't know. That's going to be x. Okay, this is the distance that Kennedy travels, 25x. Now, from the 80-mile point, this indicates that she's 10 miles from the 80-mile point. So I'm going to do this. I'm going to say that she has to go 80 miles. I'm going to put a minus 80. This is going to be an absolute value. And I'm making it equal 10 because she's 10 miles from the 80-mile point. 10 miles from the 80-mile point. So I've got two options here. I split it right now. I have the positive and the negative. I'm going to do a positive 10 and then I'm going to do a negative 10. I'm solving two equations. On the left side, it's going to be, the equation exactly as it is. 25x minus 80 equals 10. So the left side is always going to be the same, and the right side is going to be the negative after the equal sign. 25x minus 80 equals negative 10. So we're still practicing solving. The minimum and maximum, or I guess I can write it right here, sorry. The cruising speed of Kennedy's boat is 25 miles an hour. She plans to cruise at this speed for 80 miles plus or minus 10 miles. Like, she might go 70 miles and she might go 90 miles, plus or minus. So I'm doing two versions. So the minimum, the least amount of time that she will be spending. So let's add 80 to both sides. I guess we can solve this in the lower portion, but 25x, I'll bring it down, equals 90. Divided by 25, I'll just tell you the answer. It's 3.6. This is the max hours she'll travel. Maximum. So that's one side of the equation, the positive 10. This next one, I'll solve. 25x equals 70. So she's only going 70 miles this time. And when I divide 2.8 hours, this is the minimum hours she'll travel. So if she goes over by 10 miles, that's 90 miles, she'll have to be driving in her boat for 3.6 hours. If she only goes 70 miles, 10 less than 80, she'll do 2.8 hours. Let me hear. Okay. All right. So what I've got for you, and I want to show this to you on the video, we're going to do some of the equations here. This is a two-sided. You're going to have side scratch paper, okay, for this. So when we have math problems like this, you're going to say x plus 5 could equal 12, the same. And then the negative, because in positive 12 and negative 12, x plus 5 equals negative 12. So I'm going to have the positive version and the negative version. If it's something like number 6, I'm going to have to divide by 7 first to isolate. But remember, you're doing this on a separate sheet of paper. Equals 11. So I'd have 4d plus 9 equals 11, the same. And then 4d plus 9 equals negative 11, the negative version of it. So it's two-sided. We're going to do some here, and there's bad bacteria in Arctic animals. So since bacteria bad has all equations, we're going to do this side today, but I'll explain that in just a second. All right, let me stop the video.